Hello everyone, welcome to my channel. I had started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out my previous videos to follow along. In today's video, we will work on 3 sum. The problem states that we are given an integer array and we need to return all the triplets such that their sum is equals to 0. We are also given that I is not equals to j and I not equals to k and j should not be equals to k. We should notice that the solution must not contain duplicate triplets. So for the brute force approach, we need to try all the possible triplets using 3 nested for loops and we need to check if their sum is equals to 0. We need to store only the unique triplets. So for that, let's initialize a set of list of type integer named set and n would be the length of the input array. Now let's start iterating from 0 till the n, and in the second loop it starts from I plus 1. It starts from I plus 1 because I is not equals to j. We would be iterating till the end, and in the third for loop it starts from j plus 1 because j is not equals to k, and this condition is automatically satisfied where I is not equals to k because we are starting from j plus 1. Now we need to check if their sum is equals to 0. Plus nums of j plus nums of k is 0. If it is equal, then let's create a new list of type integer, and this would be our first triplet. We'll convert it into a list where it will contain nums of I, nums of j and nums of k. Now we will sort and we will add it to the set. And let's add it to the set. At the end, we would return new array list of the set. Let's run the code. It is working. But the time complexity would be O of n cube because we have used 3 for loops, and the space complexity would be O of n because we are using some extra space in the form of lists. So for the optimized approach, the key observations would be we need to sort the array, we need to fix one element, and we need to use 2 pointers for the remaining part. We also need to skip duplicates to avoid any repeated triplets. For that, let's say we will store the result of type list of list as a result, and we will sort it first. Now let's start iterating till the end, And now, first thing, we need to skip the duplicates. So we need to check if I is greater than 0 and if nums of I is equals to nums of I minus 1. If it is equal, then we will continue, which means that is a duplicate. And now we need two pointers. One is left, which starts from I plus 1, and the other is right, which starts at the end of the array. Now, while left is less than right, we need to check their sum. Nums of I okay. Now if this sum is 0, then we would add it to the result. We'll convert it into list and we would add these 3 to the result. Then we would increment the left pointer and we would decrement the right pointer. Now to skip the duplicates, while you remember in the last valid palindrome question, we did the same while left is less than right, and if the left number is equals to the left minus 1th number, then we would skip it, which means we will increment left. And similarly, if left less than right and if this is equals to right plus 1, then we would decrement right. Okay. Now, if sum is 0, then we would be performing all these. What if sum is less than 0? We would simply increment left. What if sum is greater than 0? Then we would decrement right. And at the end, we would return result. Let's run the code. Okay. All typos. Sorry, we have to return this outside the for loop. Okay. Okay, it is accepted. Let's submit it. Yes. So I sorted the array and I used a 2-pointer approach for each fixed element, and we are skipping the duplicates to ensure we are having unique triplets. So that's it for today's problem. In the next video, we'll continue with more 2-pointer problems. Thank you for watching.